Hello everyone. In this video we're going to finish up lesson 2, which talked about graphical and numerical summaries of data. And so we're going to end this by talking a little bit more about describing quantitative data. So we've talked about measures of center, shape. We've talked about the shape, the center, and the variability of our quantitative data. And the last thing that we can add, other than center and variability, is position, measures of position. And so that may seem a little vague right now, but you'll know when I start talking about the different measures, they'll resonate with you, hopefully. So when I talk about measures of position, I'm usually talking about percentiles. Okay, and certainly you've come up against a percentile, whether it be good or bad, sometime in your life. So the pth percentile of data is the value such that p% of the observations fall below that point. So if you've ever taken a standardized test before and gotten the results back, you likely got your results in percentiles. So for instance, maybe I was in the 75th percentile on the SAT in math, okay? So if I was in the 75th percentile in the SAT for math, that means that I did better than 75% of all people who took the test. Okay, so the percentile represents the point at which 75% of the data lies below that point. Okay, so that's a percentile. A quartile is a special percentile. So we talk about percentiles and quartiles. Quartiles are just special percentiles. There are 3 quartiles. We call them Q1, Q2, and Q3. Q1 is the 25th percentile. Q2 is the 50th percentile. And it turns out that the 50th percentile, or the middle of the data, is the median. So Q2 is the median, and then Q3 is the 75th percentile. Okay, so there are 3 special percentiles that cut the data into quarters. Okay, hence why they're called quartiles. All right, so we have percentiles and quartiles, and that leads us to another measure of variability. Okay, and that measure is called the IQR, or interquartile range. You find the IQR by taking Q3 minus Q1. Okay, so the interquartile range measures the variability in the middle 50% of the data. Okay, which is just what Q3 minus Q1 is in words. Okay, so the IQR gives you another measure of how spread out the data are. And the IQR, unlike the standard deviation or the mean, is a resistance measure. It is not affected by outliers. So of the 4 major things that we're going to use to describe center and variability in this course, the mean and the standard deviation are not resistance measures, and the median and the IQR are resistance measures. Okay, so write that down. Remember that somehow, because that is important. Okay. Now, another thing that these percentiles, quartiles, and IQR-ish type stuff are good at are describing or detecting outliers. Okay? So, an observation is a possible outlier or potential outlier if it lies more than 1.5 times the IQR above Q3 or below Q1. Okay? Again, that may not make so much sense. I'll have you do a reading assignment that explains that much more clearly. Okay. when you put all these together, you actually get a new plot. That's another very common plot of quantitative data, and that is called a box plot. Okay, so we can use these values to make what's called a box plot. Okay, or you may know it as a box and whisker plot. Okay, so it has a box in the middle, and then it has whiskers on the ends. Okay, so I'll go through here in some detail what a box plot is. Okay, so this is a box plot of one variable. Okay, and the most important part is really the box in the middle. The left side of the box is Q1. Okay, and then there's going to be a line in the middle that represents Q2, which is the median, and then the top of the box, or the right-hand side of the box, is Q3. Okay, so that's how the box is formed. Then the whiskers are formed using partially this Q1 minus 1.5 times IQR and Q3 plus 1.5 times the IQR idea. Okay, so if you look down here, okay, this actually doesn't go down to Q1 minus 1.5 times the IQR. Okay, so this whisker, so to speak, only goes down to some point here that's actually not far away from Q1. That's because this left-hand side here, this point, is the lowest point in the data. So it in this case, goes to the minimum. However, up here, the whisker goes all the way out to Q3 plus 1.5 times the IQR. Okay, and then anything above that, which there are a lot of them here, are actual points. Okay, so it looks like this is a line. It's not. It's actually an extremely large number of points here. Okay, so these are all points. Anything above that whisker is a potential outlier, and so gets denoted in a point. Okay, you don't really need to know how a box plot is created, but you will need to create them. Okay, but of course that's easy with statistical software. Okay, but know that these endpoints, okay, are either the min or the max of data, or they're these endpoints. Okay, if the endpoints, if these equations go out farther than the min or max, then the point is either the min or max. But if the min or max is larger than these endpoint-ish things, then it's the endpoint things. All right, so let's not dwell on that. We'll just move forward. So I want you to read, so the empirical rule and the z-score stuff should be not here, back with the other stuff. I want you to read pages 66 to 72. That will hopefully make clearer or reinforce your knowledge of measures of position and box plots. Okay, forget the other two there, empirical rule and z-score. You've already read them, hopefully. Okay, the last thing I want to mention is that all that we've done so far is with one variable or one group. Okay, but most interesting questions talk about multiple groups. And so it's not that we can't do that, we just haven't yet. So I want to give you a preview of coming attractions, so to speak. I can use histograms and box plots to compare multiple groups. So I've done this here. This is from the this is from the Diamonds data set that you've seen before. Okay, and I've plotted a bunch of histograms here, side by side, so to speak, in a matrix form. Okay, and so you can use this to compare different groups. Okay, you can compare their shape, their center, and their variability. And you can also do that, the same picture, with box plots. Okay, they each do something different. They each have their pros and cons that we won't really mention later. I just want you to know that this exists.